This is a lesson about calculating density. We've talked about density briefly a week or so ago when we were looking at physical and chemical properties. Density is a physical property of matter, and it is an intensive physical property, which means, remember, that it does not depend upon the size of the sample. Remember, we talked about if you have a cup of water or 2 cups of water. The 2 cups of water will, of course, have twice the volume, but they will also have twice the mass. And since density is a ratio of mass to volume, those twos will divide out, and the density would be the same for the water, whether you had 1 cup or 2 cups. What we want to do in this lesson is practice various ways to calculate density, manipulate the equation, and also be able to solve for the other variables like mass and volume. Apply water displacement to determining the density of an object if it's irregularly shaped, and then just extend it a little bit into what's specific gravity and some of the uses of specific gravity. So here's an example question that you might have where the density of an object or matter is given. In this case, it's silver. Remember, it's an intensive physical property, so this is always going to be the density of silver. And it says here, determine the mass of a cube of silver that measures 2 centimeters on each side. So we know the density, and we have the means to calculate the volume, but we want to solve for the mass. So one of the first things you need to do is a little bit of algebra. You want to cross multiply or multiply both sides by the volume. And you can see that taking the density times the volume will give you the, mass, because the volume will divide out over here. And on this side, the density and volume, you need to multiply them, and then that will give you the mass of the cube. So in some of these problems, you're going to have different regularly shaped objects like cubes, spheres, cylinders. You need to, if you do not know the equation to find the volume of a regularly shaped object, you want to look that up. The two that I will expect you to know for the test, I'd want you to know the volume for the cube is, side cubed, the length times the width times the height. And if you have a cylinder, the volume of a cylinder, basically it's circles stacked up. You need the area of the circle, pi r squared, and then how many of them are stacked up times the height. In every case, when you are calculating the volume of a regularly shaped object, you should end up with a distance cubed. Like here, the length of the side cubed. Down here, the radius squared times h. If the radius is in centimeters and the height is in centimeters, again, you're going to end up then with centimeters cubed. So that's something to keep in mind, that you've got the right, or at least hopefully have the right formula for the volume of a regularly shaped object if you do end up with cubed distance dimensions. So this one is where we need to take the length of the side, and we need to take the length of the side and cube it. So we've got the volume is going to be equal to the 2.0 centimeters. Got to cube everything. So this means you got to cube the number. 2 cubed is 8. Got to cube the unit. Centimeters cubed is centimeters cubed. And now we know the volume of our cube of silver. We know the density because it's given. We know the volume because we just found it. We multiply them and we're going to get the mass. One of the things that you're going to have to really be careful about on WebAssign, they love to make you work a lot with different units and match up your units and unit conversions. This one's pretty easy because centimeters cubed and milliliters are the same thing. So if the volume is 8 centimeters cubed, it's also 8 milliliters. But, you have to pay attention to the units, and you might need to do some dimensional analysis, do some unit conversion before you plug it into the density problem. So here we're going to take our density, just given as 10.5 grams per milliliter. Going to multiply that by the volume in milliliters, which is the same as the centimeters cubed. And when you multiply those, you get 84. The milliliters will divide out, and the unit for your answer is grams. And that's your final answer. So you might have problems with regularly shaped objects that are spherical, cones, cylinders, etc. Like I said, look up what is, if you have a situation like that, you may need to just look up what is the formula. You need to know this one, and you need to know the cylinder volume is pi r squared times height. The other ones you can look up when you're working on WebAssign or book problems and use the given formula that you find. Different variables might be missing in the density problem. You might have mass that you need to solve for, like in this one. You could have volume or you could have density. They'll mix it up along the way. So this is one that is a water displacement problem. Give me a second to read that. And anytime you have something that will not dissolve in or react with the water, if it does not have a regular shape, you can put it in water and use the displacement that is measured to figure out the volume of the object. Now, the object, remember, has to not react with the water, not dissolve in the water. It also has to be completely submerged when you're using this method. Now, you can see here that the water originally is 25 milliliters, and then it rises up to 28.5. So you just take the difference, and of course, you end up with 3.5 milliliters, and that's the volume. So the volume is very easy to find when you're doing water displacement. Now this one gives us the mass in the problem, and we are to determine the density. This one does not even require algebraic rearrangement. We have the mass, we have the volume. You can divide, and in this case, you get 2.7 grams per milliliter. Now, since the density is an intensive physical property, we can use it to identify the metal. So you just refer to the list of known density values, and you can see that this was a chunk of aluminum. Yes, it was silver colored, but the actual identity was aluminum. You're going to see a number of different problems like this in the homework and on WebAssign. Here's another example of a problem you might need to solve. This one looks pretty easy. You don't need to calculate like a volume using a formula. You don't need to change any of the units. The mass and the density both have gram units. What is tricky about this one though, and the reason I have this in here, is that my students often have a little trouble solving for a variable like this that is, on the bottom. Okay. When you're solving for a variable that is on the bottom, you want to first get that variable to the top. So I'm going to, cross multiply or multiply both sides by v. Now I want to isolate this variable. So now I'm going to divide both sides by the density, and I see that the volume is going to be equal to the mass over the density. Now, if you've done your algebra right, when you plug your numbers in and you include units and you solve, you should get something that makes sense. Like if you look at this one, the grams will divide out. And in the units, you're left with 1 over milliliters. Well, just like you've learned in math class that you can take 1 over x and you can invert the fraction on the bottom and multiply, you can do the same thing with these units. It doesn't have to be just numbers. Units follow the algebraic rules too. When I invert and multiply, I get milliliters, which is indeed a volume unit. So that makes sense. And when I solve this one, I got 6.48. The other thing you can do at the end of a problem to make sure that you've done your algebra right, you can plug the mass and the volume back into the density equation and make sure that you get the density of 19.3 grams per milliliter that was given in the problem. So when you are doing algebra, if you doubt your algebra at all, or if you just want to double check your answer, that would be a good strategy. Now, I didn't put any in here for you to practice on your own because you are going to get quite a few of these in the lab and homework and WebAssign, etc. And many of you have done density problems in the past. So moving on to specific gravity. Specific gravity is just relative density. Excuse me. It's just comparing the density of a substance to the density of a given reference material. Okay. For liquids, the reference material is often water. For gases, it's often dry air. But it doesn't have to be. Take, for example, one of the uses of specific gravity, which has no units, one of the uses is in the food industry for syrups, honey, juices. For example, let's say you're producing syrup. You have to make sure that you have syrup that's not too thick or not too runny, because when you, for example, buy like a bottle of log cabin syrup, you open it up and expect a certain consistency. So what they do is they have this reference material. Here's what the density of the syrup should be. And as they're producing batches of syrup, they will measure the density and compare it to the reference material. And it has to be within plus or minus so much of the reference material to know that, yep, this is a good batch. If it's too thick or it's too thin, if it's too thick, the density is going to be too high. It's got too much sugar. If it's too thin, the density is going to be way too low. It doesn't have enough sugar. That batch is not going to pass, the quality control check. But specific gravity doesn't really have any units. It's just a ratio of two densities. And some of the main uses, mineral identification. During the gold rush, they would just compare the, object or like chunk of metal that someone found to real gold to determine if it was, likely to be pure or real gold. Urine analysis, I've seen it used in medicine to compare urine that has of a diabetic person that has too much sugar in their system is going to be very dense. And, then if there's a really, really low blood sugar, it's going to be of a lower density. So I've seen it used in these. It's not something that I've ended up having to use in like experiments and research, but I have seen some students use it for mineral identification in science fair projects or, projects that they've done involving just different, how do you want to say, different products on the market, etc. like measuring the viscosity and how does, the viscosity and the density change and change temperature, etc. So I've seen some students use it, but no, it is not, extremely common that you're going to run into having to use it. It is, however, part of the state curriculum. And so let's practice a problem. You can see here that we've got a rectangular block. We have the dimensions in centimeters, and we have the mass. So the first thing you want to do is determine the density of the block. Okay, so go ahead and do that. After you've determined the volume of the block, you can move on and find the density of it. Now, the volume is 91.494. And for some reason, that's having a hard time picking up my marker. And that is centimeters cubed. When you're doing WebAssign problems, I would keep all those extra numbers. When you're not, it's up to you because these all have 2 sig figs. So 91, if you round it to that, that's fine. When you're doing WebAssign, though, I wouldn't round until the very end. So then to find the density, you're going to put mass. There we go. It's writing a little better now. And you're going to put that over the volume. So calculating that. And that I am going to round to 2 sig figs. And I got 0.72 grams per centimeter cubed. So that's the density of the block. We want it with respect to acetone. So basically, when you're finding the specific gravity, the original substance goes on the top. The reference material needs to be in the same units so that they divide out, because specific gravity does not have units. Centimeters cubed and milliliters, same thing. So they will divide out. And the answer here is 0.92. And that's the specific gravity. No units on the answer. So you're going to see, like I said, a number of problems where you get to manipulate the density equation and solve for any 3 variables, either density, mass, or volume. You may have to determine the volume of a regularly shaped object using one of those equations. If you don't know the equation, look it up. You may need to use water displacement. With the water displacement, again, you go back to that original equation. You might have to, find the mass ultimately, because water displacement will give you the volume. Use that in the density to get the mass. I've even seen problems where the mass and the density is known, and you have to calculate the volume and then predict how much the water will go up. And you may need to be able to calculate specific gravity by taking the density of an object and comparing it to the reference liquid. Remember, as with any of these, if you're starting to practice problems in homework on WebAssign or working on a lab and you're struggling at all with it, I'm always there in Wildcat every day and Flex for you to come down and get a little help. And I can meet with you, after school, as long as we make some prior arrangements and I know you're staying. So good luck. And, let me know if you need any help.